I'd like to discuss, well, respected Mr. Kakhanis and Mr. Dwivedi and all fellow delegates and friends. I am basically a metallurgist. I represent Lloyd's Register UK and as a principal metallurgical and drilling specialist. But I have travelled so many thermal power stations because of my work and of course the steel plants and many other places. I would like to tell you, this is safety and energy conservation as tools to care people, planet and profit. That safety, starting with the safety word, I have at least, I was just counted, I might have gone to about 900 industries so far. I am 74 now. But there is no safety in India. It's very difficult. Last week I had gone to Nilkant Concast Private Limited for TMT bar. Have you heard of TMT bar? Can somebody tell me what is a TMT bar? That is for concretizing. You know, earlier days we used to go for the plain rods which used to put inside the concrete. After that, the twisted thing has come. Great. After that, now it is the most recent is called TMT. It is called thermomechanically treated bar. So there is a thermal working and there is a mechanical working. So it is called thermomechanically treated bar. And there is a furnace, electric furnace. There were 3 induction furnaces and all that. No safety. I had to climb up. There's a rolling mill. There's a Thermax quenching system given by Germany and all that. Very badly kept. But somehow they are maintaining the quality and all that. And that is the Indian approach, which I like to say that safety. I've got down some very important points for safety, which I would see Industry 4.0. My points are all relating to Industry 4.0. And those points you as a young engineers and young specialists, I would definitely request you to see all those points. Can I have that slide, please? Yeah. Sir, you can general see industry safety rules.
So you can see, no? You will not able to see.
If you want to use podium, you can use that also.
No, you can go to podium also, sir. If you want. Podium mic is there.
Yeah, that's good. Thank you.
Podium mic.
Hello. Hello, can you hear me? Yeah. Treble, please. Treble. Hello. Hello, check. 1, 2, 3, 4, check. Fine. So I, based on my industries, and this is of course some documents which I have taken from Lloyd's Register, because we have to be in a confined space, how to work on a confined space, how to work on a steel plant, how to work on a thermal power stations and all that. So from my experience and a little bit of guidance I have taken from my own organization and their safety behavior systems. These are the points which I would like you to kindly concentrate. Your safety is your personal responsibility. Always follow the correct procedure. Never take shortcuts. This shortcuts is a very important thing in India. Everybody takes shortcuts. And there are so many accidents and all that. Take responsibility and clean up if you made a mess. Clean and organize your workspace. Ensure a clear and easy route to emergency exits. Very, very important. We do not know. We go to many hotels also stay. There is no particular aligned emergency systems are there. Industry is very, very important. And especially, I used to go to rolling mills and all that. The entire power stations, all the motors and all that, they're below the earth. And there's a motor room and all. I do not know if something happens there, how to escape. Many, I had gone to Bhilai steel plant, I had gone to Rourkela steel plant, and Bokaro steel plants and all that. They have all done that, but the emergency exit is not there at all if something becomes a problem. Very difficult. I as a metallurgist, when I used to go for checking something, I used to scare that if something happens, how to go. Be alert and awake on the job. Next page. The requirement of industrial safety is to prevent any kind of incidents resulting in the accidents causing loss of life and permanent disability of the employees in the organization, damages to machine and materials causing organizational losses. Today, energy conservation plays a big role in industry. So that was the point I just wanted to make. I was told that time is very limited, but these are the points of safety what I have covered. My request to you, kindly look into these points, because India, when we are working as an engineer, is very unsafe, very, very unsafe. I had gone for a blast furnace expansion at sale at Burnpur just about 5 years before. There I had to go, and that was erected by Korea. But even then, there you had to climb up almost about 25 meters and on a run, and there is no safety there. So I was very scared to go up and do some of the inspections and all that. So today, so after the safety, and there's now highlighting on energy, today energy conservation plays a big role in industries. Energy conservation not only has a positive effect on the energy efficiency, but also implies a reduced use of energy sources integrated with the recovery of the waste energy. This is very important. That is a profit. If you can reduce the use of energy sources integrated with the recovery of the waste energy, that is the modernization program. Many of the places we do waste heat recovery system, and we try to modernize so that the energy is reduced, and that means that is a profit. The fundamental that profit, taking care of the people, profit, and
Planet.
And what is the next?
Planet.
And planet, yes. Next. Provision of the opportunities, this is energy conservation. As I felt, provision of the opportunities to decrease the specific energy consumption. To decrease the specific energy. Provision of good practices to utilize energy sources more effectively. Provision of good practices to recover waste energy, that is basically heat and gas. I am meaning here thermal power stations and all that. We have a lot of gases on the stack, flue gases going out. The sensibility is about 600 to 700 degrees centigrade. Those heat we can absorb and divert in a proper way. 600 to 700, can you imagine? I have seen stack which is going 1000 degrees centigrade. The chimneys become red, hot red. Nobody cares. Nobody cares. So provision of good practices to recover waste energy, heat and gas wherever practicable. To enable the plant management to develop plans for plant energy intensity reduction. Plant energy intensity reduction. To use benchmarking techniques for prioritization of investments to maximize the energy conservation and adopting good practices with the biggest impact. It's a very important point for the managers or the budding managers that when you invest something, you think it very rationally that what kind of modernization you are going to do. Like Mr. Karkani was telling about ash. Now 35% ash is a very, very big problem. It will give you TB. I worked in Vilai Steel Plant as a surveyor, and there is something called sintering. And during the making of sintering, it is called a TB plant. And they get extra benefit out of that. Their incentives are more because the life expectancy will be much less compared to a normal life. So they are paid. And people are working, that is the Indian style. But nobody thinks that how to take care of ash content there, how to make it a sintering plant better so that a man working in a sintering plant should have the proper life like a normal man's life. Several approaches for conservation energy. These are important for you. System approach, monitoring approach, energy balance approach, optimization approach for a generation and usage of byproduct fuels. Byproduct fuels, important. Energy audit approach, waste energy recovery approach, approach to select cost-effective energy mix, energy management approach, automatic control approach, approach of investment to energy conservation equipment and technologies, and energy benchmarking approach. Next please. Improvement in the energy efficiency and lowering the energy intensified resulting into substantial cost saving, and that is the profit part of the main topic. Decrease uncertainties and reduce exposure to fluctuating energy costs. This fluctuating energy, even in many electrical systems I have seen that is a perpetual problem. The fluctuation that costs energy, and that is increasing, there is losses. So we have to see how to stabilize the fluctuating situations in the electrical industries and also thermal power stations and all that. A lot of fluctuations. Pick up. Decrease uncertainties and reduce exposure to the fluctuating energy cost. Disciplined working resulting into increased product quality and improved process productivity. Reduction in the environmental emissions, very important, environmental emissions and improved compliance of the environmental norms. Here only the ash content, the sulfur content, we use coal pulverizer, coal gasification plant and all that. So a lot of sulfur is going on. Nobody thinks about the sulfur, how to desulfurize, how to balance, how to do the energy balance, how to optimize that sulfur content so that, sulfur goes to air, and if we inhale, what is the result out of that. So emissions and improved compliance with environmental norms. Optimization of the purchase and consumption of all types of fuels and energy inputs. Provision of an efficient system for comprehensive management of all major energy flows within the industries. This is very important, the provision of an efficient system. Can somebody tell me here, this is a very comprehensive management of all major energy flows within the industries. If you go to a steel plant, because I'm basically a steel plant man, while they make the coke and the coke oven gas, that gas is carbon monoxide and C3H8, C4H9 and all those, and they store it in a stove, and from that they supply to all, like your steel making in open earth furnace or ALD furnace, it goes to the heat treatment shop, it goes to the rolling mill. So the answer, the provision of an efficient system for comprehensive management of all major energy flows within the industry. So industry, when I'm making coke, I'm getting carbon monoxide and all these gases that I'm preserving on a stove and utilizing in various processes within itself, within the industry. Very important engineering work for optimization. Effective use of media pressure energy, sensible and physical heat of flue gases and fumes. SOx and NOx. SOx is sulfur dioxide, sulfur trioxide, these are called SOx. NOx is nitric oxide, nitrous oxide and all that. Highly injurious, highly damaging. Thermal power station. Next. There is one more. From the thermal power station, steel plant, coal gasification plant, coal pulverizer, high amount of sulfur in the air through the flue gas desulfurization system. Also trouble faced by high ash content by the use of coal, leading to high particulate content in the flue gas, bringing air quality index very high. Nuclear energies, I've been to some nuclear applications also. The nuclear energies are emitting high radiation causing harm to plants, trees, animals, fish. You must have remembered that Fukushima affair in Japan, where they have made it, and most of the abroad, of course Japan, nuclear energy is almost about 45%. And the remaining is thermal power and hydropower and all that. 40% is nuclear energy. So any waste of nuclear energy they are putting inside the sea. But when you put inside, that is why the plant is also by the side of the sea. But when you put that into the sea, what will happen to the aquatic animals like fish and all that? Very problem. I remember after the installation of Fukushima plant, 2 years, Japanese could not able to sell fish. It was banned in that country. So nuclear energy is emitting high radiation causing harm to plants, trees, animals, fish and human beings. High rate of pollution created by SOx and NOx are very harmful, damaging the planet Earth. Thank you.